So hi guys, we will be continuing the discussion on dimensions of physical quantities. Let's start with this CBSE textbook. What do you mean by dimensional formula and dimensional equation? So let me give you an example. Let us take V as the velocity. So what is the dimensional formula? It will be meters per second. So for meter the dimension will be L, and for second it will be T. So if we represent it in terms of MLT, then it will be M0 L T minus 1, right? And what is dimensional equation? An equation obtained by equating a physical quantity with its dimensional formula. It is called as dimensional equation. Okay. So there's nothing not a big difference between what is dimensional formula and dimensional equation. Now what do you mean by dimensions of physical quantities? So dimensions of physical quantities are the powers or exponents to which the base quantities are raised to represent that quantity. For example, force is mass into acceleration, and what is acceleration? It is meters per second square. So there is a square of second in its dimensional formula, so it will be MLT minus 2. So what is minus 2? It is the dimension of that physical quantity in this dimensional formula. Okay. So dimensions of force are MLT to the power minus 2. The force has one dimension in mass, one dimension in length, and minus 2 dimensions in time. The dimensions in all other base quantities are 0. Similarly, a change in velocity, initial velocity, average velocity, final velocity, and speed are all equivalent in this context, right? So since these quantities can be expressed as length per unit time, their dimensions should be LT to the power minus 1. So there will be one dimension on length and minus 1 dimension on time. So guys, I'll just explain you the dimensions of physical quantities. So here all the physical quantities can be expressed or derived in terms of some combination of 7 fundamentals or base quantities. So what are those 7 fundamental quantities? Length, mass, time, electric current, thermodynamic temperature, luminous intensity, and the amount of substance moved. So all physical quantities can be expressed in terms of these 7 basic quantities. What are dimensions of physical quantities? So the dimension of physical quantities are powers or exponents to which the base quantities are raised to represent that quantity. So if we talk about force equals mass into acceleration. So how is acceleration represented? Meters per second square. And what is mass? It will be m. So this is how we can write m into a is meters per second square. So L t to the power minus 2 meters per second square, right? Meters per second square. And this is mass, right? So length can be expressed in, or you can say the meter can be expressed in terms of this L. Seconds can be expressed in terms of t, right? T is the time, and mass can be expressed in terms of. So these are all within the square brackets. Now what do you mean by dimensions of physical quantity? So basically the power. So here the power is 1, here also the power is 1, and here the power is minus 2, right? It means that these are the dimensions of physical quantities. So base to the power is the dimensions. Now 1.5, what are dimensional formula? So let's say dimensional formula of is equal to meters per second square, right? Meters per second square, right? So how is it written? LT minus 2. So the expression which shows how and which of the base quantities, right? How and which of the base quantities represent the dimension of physical quantity is called as dimensional formula. So this is the dimensional formula. An equation obtained by equating a physical quantity with its dimensional formula. So V equals LT minus 2. Okay, this is dimensional equation. This is dimensional equation. So an equation obtained by equating physical quantity with its dimensional formula, right, is called as dimensional equation. Let us write for volume. It is capital V. So what is the dimensional equation? V is equal to m to the power 0. Dimension will be 0. L to the power 3. So 3 dimension of length, and t to the power 0. 0 dimension of time. This is how volume is written. Right, this is how volume is written. Now let's write velocity. So it is small v. This equals m0 l t minus 1. So This is how we can write it. So Lt to the power minus 1. How to write force? M Lt to the power minus 2. If there is nothing, it means it is 1, right? kg meters per second square, right? This is the SI unit. Now what is density? So it is rho. What is density? Mass per unit volume. So ml to the power minus 3 t to the power 0. This is the this is the dimensional equation of density, right? So you can check appendix 9 in CBSE textbook. So 1.6 is dimensional analysis and its application. So let's see this. So what is the application of dimensional analysis? So a thorough understanding of dimensional analysis is used to check the interpretation of various equations, relation among different physical quantities, and checking the derivation, accuracy, and dimensional consistency or homogeneity of equations. So we come to 1.6.1, that is checking the dimensional consistency of equation. So the magnitudes of different physical quantities can be subtracted, added if and only if they have same dimensions. So velocity cannot be added to force, length cannot be added to mass, right? So the dimensions has to be same. Then only the quantities get added or subtracted. So this simple principle is called as the principle of homogeneity of equation, which is extremely essential in checking the dimensional consistency of the equation. So if the dimension of all the terms are not same, then the equation is wrong. Dimension means the power of the base quantity. So the dimensions are customarily used as the preliminary test for balancing the equation when there is some doubt about the correctness of the equation. But I would like to stress here that the dimensional equation, if it is the dimensional equation, does not guarantee the correctness of the equation. Okay, why? Because there can be some constant, there can be some power. Okay, so trigonometric, logarithmic, exponential, all these functions are dimensionless. Okay, all these functions are dimensionless. A pure number or any ratio of physical quantities such as angle, that is L by L. Okay, refractive index. What is refractive index? Speed of light in vacuum upon speed of light in any medium. Okay, so these are also dimensionless quantities. Now let us test the dimensional consistency or homogeneity of the equation. Okay, let's say x equals x naught plus 1 by 2 a t square. So this is the distance x which is traveled by a particle which is traveling at acceleration a and in time t. So that particle is traveling at for time t with an acceleration a. Okay, so how can we write the dimensions of each term? So for this it will be L. For this x naught it will be L. There is one more term V naught t. So what is V naught? So it will be L t minus 1. And what is t? T is okay. So what it becomes? This t and this t gets cancelled. So the final is L. Let's consider this 1 by 2 a t square. So what is the dimensional formula for acceleration? It is L t minus 2 and this is t square means t square. So here also t to the power minus 2 and t square gets cancelled. So the dimension is L. X equals x naught plus v naught t plus 1 by 2 a t square. Its dimension is also L. So this is also L. This is also L. Hence the equation is dimensionally consistent. Okay. Let us consider example 1.3. 1 by 2 mv square equals mgh, where m is the mass of the body, v is its velocity, g is the acceleration due to gravity, and h is the height. Check whether the equation is dimensionally correct. So what we will do, we will first write the dimensions for this. We do not consider these constants, only we will take the dimension of the base quantities. So for m it will be mass, and here it is v square. V square means meters per second, Lt minus 1, and it's square. Okay. How about this mgh? M means mass, so we will write it as m. G is acceleration due to gravity, that is meters per second square, so L t to the power minus 2, and h is length, or you can say height. So it has also the dimension of L. Now let us solve this. M L square t to the power minus 2. What about right hand side? M these 12 you can multiply L square, and this is t to the power minus 2. Both side the dimensions are coming equal. So it means that MGH is dimensionally similar to half mv square, right? So kinetic energy is dimensionally similar to potential energy, right? So this is the potential energy, this is the kinetic energy. Let us do example number 1.4. The SI unit of energy is joules, and that of speed v is meters per second, and acceleration a is meters per second square. Which of the formula for kinetic energy given below can you rule out on the basis of dimensional arguments? M stands for mass. So what are the options? Option is K is half, K is 0 and A is 16 and A is. So we are given this unit of K, that is kinetic energy. It is joule, and it is given as kg meter square per second square. So let us write the dimensional formula for this energy. So it will be M L2 t minus 2. Now let us check which is having the same dimensional equation. So this is having same ml2 t minus 2. What about ma? So m acceleration meters per second square, l t minus 2. Okay. So this is not equal to 2 t minus 2. Okay. So this is consistent, this is consistent. What about this? This is not. What about this? This is also not. Okay. So every correct formula or equation must have the same dimensions on both sides of the equation. Also, only quantities with the same physical dimensions can be added or subtracted, right? So this cannot be added to this because this is force and this is kinetic energy. You cannot add force and kinetic energy. Okay, now let us go to next 1.6.2, deducing relation among the physical quantity. So this method of dimension can sometimes be used to deduce the relation among different physical quantities. Okay, let us do example 1.5. Consider a simple pendulum having a bob attached to a string that oscillates under the action of force of gravity. Suppose that the period of oscillation of the simple pendulum depends on its length L, mass of bob m, and acceleration due to gravity v. Derive the expression of its time period using method of dimensions. Okay, so time period, so period of oscillation depends on length. Time period of pendulum is directly proportional to length. Okay, length, acceleration due to gravity, and mass of the bob. So how is simple pendulum? So this is the string, this is the bob string. Okay, and it will go like this and it will come back, it will oscillate, right? So derive the expression for its time period using method of dimensions. So how do we do that? For deriving the dimensions, we need to consider certain variables. Let x, y, z be the dimensions of L, G and M respectively. Okay, so time period of simple pendulum will be dependent on L to the power x, G to the power y, and M to the power z. Now let us write it in dimensions equation. So for t it will be M to the power 0, L to the power 0, T to the power 1, right? What about the right hand side here? L to the power x. Okay. What is G? G is meters per second square. So L T to the power minus 2 to the power y. And what is m? This is m to the power z. Now equating individual, so m will be equated to m, equated to l, and t will be equated to t. Okay. So m to the power 0 equals m to the power z. This means that z equals 0, right? Z equals 0. Now we'll go for L. So the power of L is 0 on the left hand side, and here L to the power x, and what is this? L to the power y. Okay. So 0 equals x plus y. What is the identity? A to the power m, a to the power n. If you multiply it, so it will become a to the power m plus n. Okay. So this is equation 1. Now let us go for considering t, dimensions of t. So here t to the power 1 on the left side, and what is on the right hand side? T to the power minus 2y. Okay, any other? No t is there. So 1 equals minus 2y. So what is y? Y is equal to minus 1 by 2. Y equals minus 1 by 2. This is equation 2. So from 1 and 2, x is equal to plus 1 by 2. Now just put the values of x and y here. So L to the power x, it is L to the power 1 by 2, and g to the power y. So g to the power minus 1 by 2 is equal to time period. So what it is becoming? Under root L by g. Or you can say Tp is equal to k under root L by g. So this is the time period of simple pendulum. So there is certain value of k which we'll see later. So this is how you can even come close to deriving the equation of any physical quantity. Okay. So the value of k cannot be obtained with this method, right? So there is certain other methods where we can find out the value of k. So here we comes the end of the topic. So now we will be coming to the exercise part. So after this we will go for solving the numerical based questions which have already come in competitive examinations such as IIT Mains and NEET. So please like, share and subscribe. Don't forget to comment. Thank you.